So hello students, we'll continue again with unit number 1 and topic number 8, which is cranes, hoist and other equipments and material transportation equipments. So the first topic is cranes, hoist and other equipments for lifting purpose. Types of hoisting equipment in construction. The hoisting is the lifting of the material against gravity and may be done with a wide range of equipment, from the small hand-operated simple screw or hydraulic jack in order to modern high-power cranes and elevators. Hoisting is lifting a weight from one location and moving it to another location which is at a reasonable distance. Big projects such as the construction of dams, industrial buildings, etc. require hoisting equipment. Hoisting equipment includes jacks, winches, chain hoist, and cranes. So what is crane? Crane is the only single machine which, as a single piece, is capable of providing three-dimensional movement of the weight. Types of hoisting equipment in construction. The common equipment used are as follows. Number 1, pulley and shift block. 2, chain hoist. 3, mobile cranes. 4, winch. 5, jack. 6, shear leg. 7, tower cranes. 8, wheeler cranes. 9, derrick cranes, and 10, gantry cranes. First one, movable pulley. So what is the pulley? It is a wheel on an axial or shaft which is designed to support movement and also change of direction of a cable or belt along its circumference. Pulleys are used in a variety of ways to lift loads, apply forces, and to transmit power. In nautical context, the assembly of the wheel, axle, and supporting shell is referred to as a block. So a pulley may also be called a sheave or drum and may have a groove between two flanges around its circumference. The drive element of a pulley system can be a rope, cable, belt, or chain that runs over the pulley inside the groove. Next, rope and pulley. So the pulley and sheave block suitable for lifting rough surfaces and heavy loads. So for this purpose, the chains and wire ropes are used. The alloy chains are best suited for hoisting operation. The weakest component of the system is the load hook. So the hook fails by straightening. Once the hook gets elongated or straightened, it should be replaced. Next, chain hoist. The chain hoists are the popular mechanism for lifting loads of up to tons. So the system consists of two sets of chains, namely the hand and load chain. So hand chains are particularly useful for the isolated location where an electric motor or other types of mechanical equipment are not available. The pull applied to the hand chain is transmitted to the load chain with a multiplication factor of over 20. The load to be lifted is held by a load hook, while another hook, which is called the support hook at the top, supports the mechanism. The two hooks, however, should not be interchanged, as the support hook is made much stronger than the load hook. There are 4 types of hand-operated chain hoist and are in use. Differential, screw-geared, spur-geared, and pull lifts. The first one in this picture on the extreme left is differential, second one in yellow is screw-gear, third one is spur-geared, and the fourth one is pull lift. Next one is mobile crane. Mobile crane is used in big construction projects for lifting heavy loads. It is used for loading and unloading for material in coal mines, loading and unloading of ships. So to take the load from the ground level and place it into the trucks. Next, electric winch. A winch is a mechanism in the shape of a cylinder or drum over which rope or chain is wound. So if a winch is used only for raising and lowering, it is sometimes referred to as hoist. So the winches are of 2 types, hand winches and power winches. Next, tower crane. These are the crane of swing job type and are mounted on high steel towers. The height of the tower may be 25 to 30 meters, and these cranes are found to be suitable in the construction of tall buildings in congested areas. The ground area required for such cranes is very small. This crane is a combination of stationary and mobile units. This combines the advantages of a long boom of derrick crane and mobility of the mobile crane. The rotating structure has an outer framework. The boom is attached to the front end of the framework. The counterweight is provided at the rear end. On the diagonally opposite corners of the base, two separate motors are provided which gives movement to the center shaft. So tower crane can be seen in Guwahati near the Dispur Last Gate. I think everyone has seen that. Next, derrick crane. The derrick cranes are of two types, namely guy derrick and stiff leg derrick. The guy derrick consists of a vertical mast. This mast is supported by the number of guys and can revolve around 360 degrees. While revolving, the radius of revolution should be such the revolving structure is not obstructed by the guy wires. The power is supplied by a diesel engine or by an electric motor. A typical derrick crane is illustrated in the following figure. This derrick can be constructed up to 200 tons capacity. So in stiff leg type derricks, the guy wires are replaced by truss structure. This type of derricks is suitable for loads from 10 to 50 tons. Next, overhead gantry cranes. The gantry cranes or overhead cranes are the indispensable machines in factories and workshops. In large workshops, there are separate machines for fabrications or repairs of the machine parts. The machine or the components which are to be repaired can be transferred to the place of fabrication or assembly in continuation or assembly with the help of gantry cranes. Hoisting equipment assists in the lifting and positioning of large heavy loads in a variety of industries, including automotive, chemicals, commercial printing, manufacturing, newspaper, paper, steel, warehousing, and distribution. Hoisting equipment provides a variety of benefits. Number one, customizable. Hoisting equipment can be customized with below the hook attachments and effectors or specialized tooling to handle a diverse variety of products and loads. Number two, ergonomics. By doing the heavy lifting, hoisting equipment takes the strain off operators, reducing fatigue and lowering the risk of injury. Number three, flexible. Hoisting equipment can be easily refitted for longer lifting capability. Next, equipment for transportation of materials. Transport equipment is used to move material from one location to another, example between workplaces, between a loading dock and a storage area, etc. That is within a facility or a site. So cranes are the variable part plus restricted area. When it follows industrial trucks, that is variable part plus unrestricted area, followed by conveyors, and conveyors are the fixed part. Next, the major subcategories of transport equipment are conveyors, equipment used to move materials over a fixed path between specific points, cranes, equipment used to move materials over variable paths within a restricted area, and industrial trucks, equipment used to move materials over variable paths with no restrictions on the area covered by the movement, that is unrestricted area, as we have already seen in the figure earlier. So last one is D, no equipment. Material can also be transported manually using no equipment. So that's all for this lecture. Now we'll see some videos. At the same time, you can give your attendance in the chat box with your name and enrollment ID. So this is your weekly assignment. You have to explain about concrete mixing, placing and transporting, and also write about the modular construction methods. You have to explain about concrete mixing, placing and transporting, and also write about modular construction methods. The last date of submission is 17th May, which is Monday. That's all. Thank you.
Ready-mix concrete. Ready-mix concrete, that is RMC, is a type of concrete which is manufactured in factories, which is called as batching plant based on the engineered mixed design. The mixed concrete is brought to the construction site by truck mixers or transit mixer. The transit mixer is of two types. One type is the concrete made dry at the batching plant, loaded into agitator truck mixers and water added during transportation. In the other type, mixed wet concrete is made at the batching plant, discharged into the agitator truck mixers and transported to the site. The drum in concrete is made to rotate till the concrete is placed in order to keep concrete in a plastic state. We will see about the manufacturing process involved in ready-mix concrete later. It allows speedy construction through programmed delivery at site, mechanized operation with the acceptable economy. Usage of RMC reduces the labor cost and site supervising cost. The consistency in the quality of concrete is maintained through accurate and computerized control of cement, aggregates, and water as per mixed designs. Usage of RMC also reduces the wastage of raw materials during storage. The main disadvantages of RMC are it requires special formwork arrangements since the movement of concrete through pumps can cause vibrations. And, if the transit mixer is in not proper condition, there is a chance in the loss of quality of concrete. Recent times for large construction works, a small batching plant is set near the construction site where transit mixers may not require. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like.
Transportation of concrete Part 1. In our previous videos, we have seen different methods of mixing concrete. Once the ingredients are mixed thoroughly, it should be transported to the place of deposition at the earliest without the loss of homogeneity obtained at the time of mixing. There are different methods adopted for transporting concrete depend upon the size of the work, the importance of the job, the distance of the deposition place from the mixing place, and the nature of the train. Some common methods of transporting concrete are as shown on the screen. In this video, we are going to see about mortar pan and wheelbarrow transportation of concrete. Mortar pan. This is the common method of transporting concrete. The pans are filled with the concrete and are passed from hand to hand, but it is slow process and consume huge labor cost. As the pan capacity is small, more and more concrete area is exposed to the atmosphere during transportation. This may sometimes lead to evaporation of water from concrete during hot weather condition. The advantage of this method of transportation is the concrete can be deposited for both above and below concreting without segregation. Wheelbarrow. This type of transporting method is used for placing concrete in ground level. This method is used for concreting rigid pavements. The wheelbarrow is fixed with pneumatic wheels to facilitate the movement. In case of uneven ground surface, segregation of concrete may occur. So, in this case, the wooden planks are placed in the path of transportation, so it will result in reduced segregation. The average capacity of a wheelbarrow is 35 liters, that is 80 kilograms. These types of transportation are used for small jobs, small hauls, and over muddy ground. Subscribe our channel for more civil engineering related videos. Of concrete Part 2. Crane, bucket and ropeway method. Crane and bucket is the recently used method for transporting concrete in high-rise construction projects. This method is being adopted widely as the cranes are fast and versatile to move concrete horizontally as well as vertically and allow to place the concrete at the exact location. The mixing of concrete is done at the ground level and transported to the location via skips or buckets attached to the cranes. The skips have discharge door at the bottom whereas the buckets are tilted for emptying. The similar type of transportation adopted for concreting in a dam or the pier, which is called as ropeway and bucket method of concreting. The concrete is mixed at the bank or abutment at a convenient place and the bucket is brought by a pulley and ropeway system. The movement of the buckets is completely controlled by pulley arrangement. As the size of the bucket is large, the effect of exposure to sun and wind will not have much effect on the concrete. In this method, concrete is discharged by tilting or by gate system attached at the bottom. The gate is controlled by either manually or mechanically. To be noted that, in both methods, the concrete is discharged from the smallest height as possible and should not be made to fall from great height. Subscribe our channel for more civil engineering related videos.